Hello, I'm Haoxiang Zhao, and this is the lab report for Lab 2, and the topic is falling object. So the purpose of our lab is to compare observation of a falling object, and we simulate the scenario with a computational model, and considering the factor of the air resistance, which is the drag force in our code, and we will discuss the result based on Newton's second law. So the law basically states that the rate of change of the velocity versus time is dependent on the external force acting on the object. And in this case is the gravitational force and the drag force. So in our setup, we have a falling object that's exactly 50 grams, and we have exact 1 meter stick to calibrate the distance the object it has moved. So here's our video. It's kind of short, and our mobile phone device has 30 frames per second, and we only record 13 frames. That is useful, as you can see. And here is my code. So in our first model, we only take account of the gravity. As you can see, the net force used the gravity directly, and this is how it goes. And by the way, we only visualize the displacement to consider how far the object has moved, because since in our case the object never changes direction. And in our second model, we take account of the drag force. As you can see, the formula is the B constant times the square of the speed magnitude and times the velocity. And we take both factors into net force, and we come out the result like this. So as you can see, the drag force tends to increase due to the increased velocity in the negative y direction, and the velocity, even though it's increasing, but it's kind of the increasing speed kind of slow down due to the decreased acceleration. And here is our result. So even though that it's really obvious, the Model 2 is much slower than Model 1 in the displacement. However, our experiment data fails to match both cases because the data recorded by the tractor fails to reflect the position of the object accurately. So which means that our experiment data is kind of useless for our conclusion. But theoretically speaking, based on Model 1 and 2, we can say that the velocity of the falling object is increasingly negatively due to the increased drag force in the opposite direction. And to our major problem, our limitations is definitely the camera resolution. As you can see that in the video, the image is really blurry that we can really not decide which position is the center mass. We also need to collect and improve our frame rate, because in that case we can collect more data for use to better estimate the position and the change of the velocity. Finally, we will discuss the what-if questions is in the case that when the initial velocity is not zero. So definitely the case the velocity seems is greater, that the displacement should be larger in the end. As you can see that the velocity start to decrease even more, and displacement also increase even more. And that's the result of this experiment, and thanks for watching.